Hello everyone, I hope you're all well. So today I'm going to take you through the superstructure. Now in the superstructure, as you're seeing in that small picture there, the rendering, it shows a sample of buildings that we are likely to come across in architectural plans and drawings, where you'll be given something like this. Aesthetics for aesthetics and also appreciating what is to become of the building. Now in the previous sections we saw that sometimes you start the entire site when it's like a bush, or like you start from ground zero. Now by the time you come to the superstructure, it's assumed that the substructure is worked on up to oversight concrete. So we are going to start our items, because this section here we're just listing items of the superstructure and also mentioning the units that are required for such items. So now right now you're having such a drawing, and it could have a lot of things. It could have external walls, the superstructure, internal walls, it could have columns, it could have pliers, it will have plenty of things. So each building is carefully tailored by the architect, or any building professional that is in charge of that project. And most of these details we can find them in the specifications for all the building materials, or even just the drawing. So as a QS, one of your biggest goal is to understand the square meters of the entire structure. Also get to understand the thickness, the types of elements that make up the superstructure, such that you start your taking off. Now in our taking off today, our assumption is we're going to have external walls. We shall have pliers. Now pliers are those projections of normal walling that usually protrude, just like the way you're seeing in this section here. I would term these to be like pliers just protruding from the normal section. They're like columns, but you can I believe you can see from there. So we also have internal walls. Then we do have the eave. We shall mention the eave. I'll be mentioning each and every section. Then we also have the ring beam, and lastly I think that's the last item. So let's dive into it. So right now we start with external walling. Now the external walling, I won't take it in blue, is this exterior part here you're looking at. The wall that forms an envelope that encompasses the built-in environment, the building itself. So that one is the external wall, and usually it's measured in square meters, where we do consider the girth, that is the perimeter, the girth. We know the girth, consider it like the length times the height. Now each wall has a specific height. Again, this is the wall, this is its length, and this is its height. That's how we're able to come up with these square meters. Then so the common descriptions, I try to come up with something here below, where we see assuming the walls are 200 millimeter thick, walling in solid concrete blocks. Now here in our structure, our superstructure, our specifications are saying solid concrete blocks, but you can come across clay, well-burned clay bricks, or you can come across hollow concrete blocks. It depends on the specifications, but usually it's advisable to either use well-burned clay bricks or solid concrete bricks for purposes of security, and usually solid blocks are really good for external walling. So you further go ahead and specify the mortar mix. It is 1 to 4, some is 1 to 3. So really it depends on the specification stated. So you don't have to just come up with your own. You just have to endeavor that you know at least these details and this detail. Then the walling, sometimes it's also stated in the drawing, but the sequence is the same. So here we follow, after mentioning the mortar mix, now you come across mentioning the reinforcement of hoop iron. You can specify the gauge, some gauge 32, gauge 24, and also this one is the width. So hoop iron is like a small strip, the small strip. You've seen how hoop iron is. I'll get a picture one day and share, where its width is 20 mm. So that hoop iron is the one that is usually used to, be laid in alternate courses. Now, assuming you're having a course here of brick, let's say laid in having a layer of brick here laid in stretcher bond. Now, in alternate courses of, usually it depends on the specifications, but in maybe every after a course or 3 courses, so hoop iron is always laid right here, like in between those courses, to ensure that the bricks are held together and they are further reinforced. So that's a description for walling. It's in square meters. Then projections, I talked about projections. Now here we come across features like pliers. So the protrusions. I came across a description here that we can use. Sorry, the spelling. It's this one here. Pliers, sorry. So we came across this, and here the description is an extra over. Now we know extra overs based on the earlier on segments. These are slightly works that are beyond the normal ordinary. So like a plier, it's also a special wall, though it has a protrusion, and its protrusion is specified here, where you say 400 millimeter wide by 200 thick. So it's pulling itself 400 wider, like from the normal. Shall see how they look, but according to this picture, you can see from here they slightly protrude from the normal. It's also taken in square meters, where we focus on the thickness is already stated, so we shall have the girth times the height. So that is for the projections. Now every building, if it's built up to the wall plate, the wall plate is that reinforced concrete member. The ring beam, sorry. The ring beam is that reinforced concrete member that is built slightly on this mark. I'll put it in black here. That's where the ring beam is most times located. Now, above the ring beam, we have the eaves filling, usually a few courses above it. Depends on the descriptions, but most times people take 3 courses, 4, 5, usually 5. It depends on the design. So that is a section above the ring beam. That's a few courses above the structure, and it's the one that receives the wall plate. So this eaves filling is also in square meters, where we consider the girth, which is the length, times the height, which will depend on the number of courses. So that's all about the external wall. We've catered for that is external walling, projections, and eaves filling. Then we do have internal walls. Now these are walls that are inside the structure, just like any building. I'll show you as we are doing the taking off. I know if you're listening to this, we shall keep track on the next segment. Now in the internal walling, these are walls that are inside. They could be load-bearing walls or non-load-bearing walls. So they also take the same square meters, where we mentioned the thickness of the wall and it's taken in length times height. Then we do have the RC superstructure. Now that is the member we talked of, the ring beam. Now in the ring beam, it's, as you've seen, reinforced concrete. So here we have concrete. We do have formwork, that is sort of the mold that holds the concrete, and we do have reinforcement, that is a tensional reinforcement for that member. So for concrete, it's taken in cubic meters, where we take length times width times height. Then the formwork is taken in square meters, where we consider the length times the width. While we also mention length times width, because here in formwork, as we are going to see in the description, then also reinforcements in kgs, as we shall see in the descriptions later on. So for the eaves filling, it's already stated. This was a description for the eaves filling, where it's almost the same materials in the eaves filling in well-burnt clay bricks. So you see the description of well-burnt clay bricks laid in. You mentioned the cement mortar ratio and also the width and the height. So now here we're talking about concrete. Concrete, this is a description I managed to come up with, where we mentioned that it's vibrated. Now vibrated, it accounts for machinery plant, which is a vibrator. Usually we vibrate concrete to remove excess weight, and also make sure that it's solid and compact. Reinforced in situ, meaning we are casting it wet. Concrete of ratio 1:3:6 in the ring beam. This is usually the class. That's some assignment for you to find out what class it is. So that is concrete, and it's in cubic meters, as we stated here. Then we do have also formwork, as we mentioned here. Now formwork here, we can consider it in square meters. Now here, swan formwork. Swan formwork is the type of formwork that gives you a rough finish. When you're done casting, it's usually rough, and that rough surface is usually treated by making it good with some finishes, unlike route formwork. Rough formwork is when you're using marine boards, and what they usually give you a smooth finish. Yeah, so here we said sworn formwork to the side. Now, if you're having formwork like this, the closest sketch I can have, where you're having some braces here. So formwork to the sides, this is the sides, and usually consider the length and the height. Yeah, then we have formwork to the soffit. Now soffits are the base itself here, where it's the width and the length. So it's always length times width for all of them, or length times height for the sides. Yeah, so that is for formwork. Then for reinforcements, usually it depends on the type of reinforcements that we are to use. I'll sketch a simple one. That is, let's say if we are to choose rectangular reinforcement where we're having these iron bars. Now here we might have like SAT12. Then we do have rings. So now this is how typically it might look. Might look on the side, where you're having a ring like this, at a given spacing, center to center. Usually it can be, let's say, 200 or 150, based on the recommendations and the specification of the structural engineer. So here, our goal here is to make sure that we get the linear length of reinforcements and then convert it to kgs. This is what we mostly look at in the BOQ. So we shall have to come across terms like d squared, methods like d squared out of 162. This is commonly used when we are converting. So this stands for diameter of those reinforcements. If it is T12, if it is for the rings, which is like T8 or R8. Yeah. So we shall come across that. This is what I wanted to show you in the items that we are going to be looking at in the superstructure. Now the superstructure ends with us accounting for the ring beam, but of course in our imagination it is the external walls, the internal walls, the ring beam, the eaves feeding. Yeah, those are the only elements that we expect in the superstructure. Yeah, thank you very much, and have a lovely time.